Christian, you're in chemistry, aren't you?
Yeah.
Have you studied this before?
Yeah, we haven't done the math. We haven't done the math for equations. We should use it.
Yeah. I'm pretty sure, I don't know, this isn't quite the same, but there's the ideal gas law. Pressure, volume, and temperature. Let's just see.
Yeah,
have you seen that? Yeah. So it's basically the same idea, except for this says it's proportional to the square of the pressure, which must be specific to this gas. But anyway, so first of all, we have the different options for our differential. We know it's not dP or just plain B, so that eliminates A and D. How about, out of those two, we're really just deciding if it's a positive or a negative constant. Yeah, since it said the volume will decrease. Yeah. So C. Cool. How'd the homework go?
Good. Yeah.
Overall good.
There was one question. Let's see.
All right. Well, we can look at it.
Yeah, 11.
11 on.
Yeah. On 7, 2.
7-2. Okay.
And 12.
Yeah. Come on up. All right. So it says which are solutions to the differential equation given there. So do you have a specific question or?
Well, I did it for first and
For what? Sorry.
well, like for number 1 for I.
Oh, okay. What do you mean you did it? What does that mean?
So like I took the
Oh, you did the double derivative. Okay, gotcha.
Put it in, and then I had a solution, but at a specific x value. So like I plugged in like this double derivative and this derivative into the first one that they gave us. And then I got it equal to 0, but at x equals 0.
So you took the first and second derivative of this one
Yes.
and plugged it in here and see if it equaled 0. Is that what you said?
Right.
Okay.
Right.
But, and then you said you had to plug in x equals 0?
Right. To make it 0.
Okay. What about the other two?
And then for number 2, I just got 0.
Without plugging an x
Yeah.
value in? Okay. How about the third one?
I didn't, because that eliminates all the other options.
Oh, I see what you're saying. Because there's not 1, 2, and 3, is what you're saying. Okay. But you're concerned about number 1.
Yeah, because I didn't get 0.
Let's just, so first derivative is 10 sine 2x. Yeah. Okay, and then second derivative would be negative 20 cosine 2x. Are you good if I just do the plus 50 sine 2x? So you're saying you had to plug in a
Just-
specific value?
No, but you combine cosine sine.
Yeah.
It's just gonna be 50 sine 2x. The 30 sine, you took.
Oh, I did. What the heck?
Yeah.
Yeah, I see what you mean.
I don't know, right.
Well, I mean, with the sine function, it can happen lots of times. Yeah. How did yours look on the second one? What was your,
I just got
like this version?
0 equals 0, like at the end.
Oh, okay. So really the question is it just one? So you said you didn't even try 3 because of that?
Yeah, because I just assumed 1 and 2 were right. Well, I would think it would be.
I meant just 2. Sorry, not just 1. Is what I meant.
Yeah, I did 1 and 2.
Okay.
If you do 3, if you do the third one, then you end up canceling the same as the second one.
And
Because
get
you
0.
get 16 c e to the 4x minus 20 c e to the 4x plus 4 c e to the 4x. And you get 0 equals 0.
Can you tell me that again? Sorry.
16 c e to the 4x minus 20 c e to the 4x plus 4 c e to the 4x. And everything cancels. And so I think that that's what it's meaning, is because
I agree.
those are the only two that are actually like circumstantial.
Yep. Because that one we can't get it, like it's not absolutely equal to 0.
Yeah.
We could make it, but it's not just, what did you say, automatically or something? Circumstantially equal to 0. Okay, how about the next one? Okay.
So are we just plug in C for Y? It says, I was confused.
Okay, well let's just do it. So what does it mean to say satisfies the differential equation?
That means that when you take the derivative of y, it will be equal to that.
Yep. So whatever y is has to be, what he said was that the derivative has to be this.
So the derivative of C has to be equal to whatever that is. No.
The derivative of
I don't know, because it
What
has
did he
this
say?
piece that says y equals c, so I'm trying to figure out how to put that in there.
The h equals dy dx equals c equals c.
So real backwards, real
And I tried to take the h rule and it was hard.
Oh,
And it frustrated me.
and you got okay. Well, another way we could potentially do this, the slope of y is what? 0, and we're given the slope function, right?
Wait, so Aiden was right. The derivative of c is.
So the- Yeah, so horizontal means the slope is 0, which means dy dx equals 0, right? So can we just plug c here and solve for for 0.
Is that dy dx equal to 0?
We have this x here though. But could we divide that up? I mean, the horizontal line has infinite x
What
values.
if we just say for the zero product property, y minus 4 equals 0?
Yeah.
C equals 4.
Yeah. That's what I was about to say. We can just divide this off. Like, here's what we're saying.
Yeah. That makes sense.
C minus 4 cubed sine pi x over 2 equals 0. So
Minus sign of
just divide that whole
Right.
thing off.
C minus 4 cubed is 0. C equals 4.
Yeah. I think that's good. Let me grab the thing and just... So 7-3. This one is just sketching them. And then the next one will use them and it will use them to find specific solutions. All right, first, I'm just going to put one up here. So this is what they look like. Okay? We're going to sketch our own, but also look at some to match them up with a potential differential equation. But basically what this is all like little snippets of the slopes of the solution to the differential equation. In other words, if we took the integral, we know that we would put plus c at the end on the indefinite, and that would be the general solution. And so this kind of models all the different particular solutions that we could come up with for that particular differential. Okay? So back to this one on the first page. Oh, those don't show up well at all on the screen. Your guys is printed okay?
Yeah.
Okay. So we have this. This is from yesterday. This is a differential equation. Thinking of 2x being the derivative of a function, what would that function be?
X.
Yeah. So we could say y equals x squared plus c. So all these little lines represent all the different possibilities that c could represent. So in other words, and I'll show you a little graphing tool, but we could have c be positive up there, or we could have c be negative up there, and just kind of sketching that in, you can see how the slopes kind of match at the various values of c. Does that make sense?
Yeah.
Okay. So I think this first sentence is probably worth highlighting, although my highlighter totally covers it up. Let's just do it this way. So it shows the slope of all the different particular equations. Obviously, it's not all. We can't look infinite directions, but you understand what it means. Yeah. So, kind of the way we can check, like pick a point. Pick an x and a y coordinate. And I'm going to try to get this a little bit easier to see. It sure isn't. Let's do my best. So, like, what if we picked 1, 1? That right there. Highlight the little line since it's not showing up. Okay, if we stick 1 in here, just the x value, it tells us that the slope, so if we use 1, 1, then dy dx evaluated at x equals 1 equals 2. Okay? Do you see how that slope roughly approximates 2, right? Okay? And if we did it, is there any horizontal ones? I can't see actually at all.
Well, it should be
Yeah.
right there.
All on the y-axis are all
Yeah.
horizontal. So, like if we plug 0 for x at any point on there, it would have a 0 slope. Okay? So if we did like 0, -1 or something. Makes sense so far. These are kind of weird. I don't totally see the point when we zoom out and see the big picture, but that's just me. Like Aiden told you yesterday, students think they're easy, right?
Yeah,
Did you guys like just in general think that last year?
yeah. Well, we didn't even go into depth. He like showed, I think this was like a half of a day.
Okay.
Like, we didn't.
And we're gonna spend 2 lessons at least, but like for AB, you will have questions on this, and apparently students think they're easy, so that's good news. But you have to know what the heck they mean.
Yeah, well, usually the questions are usually on an FRQ. That's where mine was anyways, it was on an FRQ, and it literally just asks you to draw what the possible shape of the curve goes.
Okay, so that's gonna be next time. Next, like Monday, we'll be able to do that. In other words, if I give you a slope field, draw the possible graph, is what he's talking about. But let's draw the slope field, which is super tedious, in my opinion. Okay, so here's how that works. Basically what we're going to end up doing on every one of these dots, we're going to draw some kind of a little hash mark, okay? So we basically need to find the slope, and like let's pick this point for example. So -2, 1, and figure out if our little hash mark is positive, if it's like really positive, or if it's really negative, and we're just going to put a little hash mark on that dot, okay? So in order to do that, how do we know?
Use
Yeah, we just plug the x and y coordinate into the dy dx, right? So, for example, this one is -2 times 2, so it is, I'm going to use a different color. And you can kind of eyeball, right? Like -2 times 2 is the slope of -4. So over 1, 2, 3, 4. So I need to kind of eyeball my line down to that dot. Something like that. I'm going to write a couple of these out. I don't know, let's pick another easy one. 1, -1. Make sense? Okay. So that one was -1. So that's like just directly aimed at the next one over. Do you see what I mean by tedious? Alright, let's do. Are we good leaving that one undone?
Yeah, I did it.
In terms of concept? Huh? You did it? Okay. I don't want to write it all out, but here's another. You can do it on any of them, but here's another strategy. You can make a big table, and actually, for doing this job, I think this is pretty helpful. Okay? And you can do it however you want. You could do like all the same y coordinate or all the same x coordinate, and then just start your table. So like if we pick all -1s for x, 1, 2, 3, 4, 5, and then y would just go 2, 1, 0, -1, -2, and then we can just plug it in and solve. So 2 plus 2, that's 4, and then 1 plus 2, 0 plus 2, -1 plus 2, and -2 plus 2. Well, what do you think? Tedious, right?
Yeah.
Okay. I'm gonna go ahead and finish this up. That's drawing one. It's not super big. Does it make sense though? How to do it?
Yeah.
Did you ever have to do that?
Yeah.
Okay. Let me. Well, I'll do that in a second. All right. Well. Anyway, we have this dy dx. I'm going to write it down here so it's easier to see. It says let f be the function that satisfies the given differential and write equation for the tangent line to that curve through the point -1, -2. So we have this kind of interesting looking slope field, but we can zoom in at -1, -2. Right there-ish. Okay, so what do we need in order to write the tangent, the equation of the tangent line? And what? Yeah, so we're given the xy values, so really we just need the slope by doing what? Yeah. So -1. So then our equation is just y plus 2 equals -1, x plus 1. And if you look there, and if you happen to sketch in a -1 slope, it looks right? Right? I mean, it looks like it would fit. Something like that. Okay, so on their website, on their website for this stuff that we're doing, is this GeoGebra. It's an interactive, I don't know what you call this, it's kind of like an applet. You can mess with it. Let me put it to full screen. There it is. And type in, can you guys tell me what that one was? 1 minus xy, right?
Yeah.
Yeah.
Okay. And if you want to play with this, I can post a link to it. So the density just changes how many lines we have. So sometimes it's nice because you can sort of see the shape of the function when you get more lines. What are you expecting it to look like when I turn that on? Kind of. Turn on a graph that will make a line through here. It is like a rational one. Well, it is one. So let's see. There we go. There's one version. Did you ever see those doing rational functions?
No.
So it has some kind of horizontal asymptote but crosses it. Okay, but anyway, it's kind of fun. I don't know if my pen will work. Yeah, it doesn't. So you can play with the different versions of this. Let's see if my mouse will work. There we go. And you can see how it follows the slope field. All the different ways of drawing the particular solution for that particular differential equation. So, I kind of like that one. Hi. He is. So what Aiden was talking about recently, just a little bit ago, I mean, was in the next section we're going to be drawing these in for certain circumstances, like which of all the different flow hashtags are we going to use to draw the solution. The guy that wrote this, I think it's pretty good, but he thinks of it as like like current in a river to help you figure out how the thing flows. Like if you dropped something in the river and watched it float, it would take it down and then back up and then over here it would flatten out again. Which I think is a good way to look at this, honestly. This says go immediately to Mr. King. I don't know how immediate immediately is. But anyway, kind of interesting, right? Any questions on it? Kind of boring stuff.
Wait, so what?
The
The X is like in the middle of that athletic director and the team of students.
It says King at the bottom.
Oh, where's he?
He's in the office.
Oh, yes.
Mr. King. So picking the correct slope or a differential equation for this given slope field. Just based on what we've done so far, what do you think is going to be the easiest way to do these?
I would take the integral so you can see the general trade with it.
Of each one?
Well, just kind of think about the integral, because some of them are really simple to think about, like 1 plus x. So it would just be x plus x squared, or 1 half x squared. And so you know it's going to be some sort of quadratic function.
Okay. How about this one? Well, C. Thinking of integrals.
Because you couldn't really do it.
Look for C.
Well, we can't. What? Go
They're
ahead.
going to get steeper that way and steeper that way.
Okay, and then same with these two. So I think it's an okay strategy.
Okay, so it's
Here's my suggestion. Is find either the horizontal or vertical hash marks.
oh yeah, that's fine.
Why?
Because only certain ones are going to equal 0 at that specific point.
Yeah, so I don't know. Pick one that's on like this one.
Maybe 1, 1.
Yeah, is at a point that we can actually recognize.
So that one works for the day.
And then just start plugging them in. Like 1 minus 1 is 0.
But then if
But
it
I
was
have-
that one, then
So
all of the y values would be the same.
Yeah.
Yeah.
You said for this one?
Yeah.
Yeah. Yep, so we know it can't be that one. number one, it's not even using the y, but number two, it's like what you said. Huh? Yeah, so these would all be positive 1. So we would, how would that look if like this one is always, no matter what x we pick. No, you said the y values would always be the
No,
same?
the x value.
Oh, okay. I guess I don't know what you mean by
Like,
that.
it would look the same across the line.
Yeah, so every single point on that y, or on that x value.
Oh,
every
so they
single
would
y
all
point
be
would always-
horizontal.
Yes.
Okay, I get what you're saying. This one works. How about that one? Yeah, for our chosen point, 4, 1, -1. I wrote that wrong.
Yeah.
Natural log of -1 doesn't work. Okay, and then I should write that first real quick. That's why this one is wrong, because it doesn't actually work. I wrote it backwards. That's why I was like, wait a minute. Do you see what I mean? I was looking at my point, but it's really 2, and it should be 0. So this one is 0. Is it always going to be where you can find a nice horizontal one?
No.
So how could we do it with the diagonal one?
You could look for one that's specifically warm, like has a slope of either -1 or 1.
Do you think you can find one like that for sure?
I don't know.
I'm saying I don't know if I can look at one of these hash marks and know exactly what the slope is. I suppose if you like maybe used a straight edge, you could get somewhat
You can
close.
see like where it's approaching 0.
What if we just picked one that's like on a point, like, or near a point?
Okay, and then just see what the slope is, right?
Yeah, like, make one up. Well, not make one, but pick one, you know what I mean. Like, what if we picked one at -1, -2? So, like, right here. Okay, well, 1, -2 on this would be 2. Well, that's a negative slope, so that doesn't work.
Right.
Same here. 1 minus 2 would be -1. That looks realistic, right? Is there other ones?
Students, a little reminder, we have stitching club in Miss Harrison's room in room 4.